First chapter, member functions or method calls. Member functions, typically known as methods in OOP terminology, can be implemented directly using procs, thanks to the uniform call syntax. Yes, that's what we've been using so far, where we had some kind of object defined, let's say animal, that has name and age. We could just create a procedure, like in this case speak, that the first argument is animal, this object type. And that let us later do instance of that animal.speak. So this is exactly what you would expect in an object-oriented programming language where you can, attach methods to some objects. So in this case, we define speak, and I like that they refer to it as self animal. That gives like a hint, like, hey, you're dealing with something that's like, a method that's supposed to be a part of animal specifically. So I like that, and we give it message, which is string. We can do echo self name concatenated with says and the message. Very simple. And here we have also a reminder of the syntax that if we define the type, we can just call it by the name with parentheses and give it all the parameters their names. So that's how we can construct an object. Okay. And then we call it, and these two are basically the same thing. The good part, the fun part is that when we call speak that way, we don't need to put the name, the animal itself within the parentheses. Well, here we have to. So, for me, this looks less clean because we have speak and then inside of Sparky. So, you're not going from generic to more specific. You're going in the opposite order. Well, here we get the object and then we do something specific with it, which is in this case speak. So I definitely prefer that syntax. It's easier to read and easier to, assume that, so here we're doing something with Sparky. As you might have guessed, the method call syntax is not restricted to object types. Okay, that's good to know. So we can say procedure double, and we can define it on an integer. And that will return an integer that is basically twice as much. So you could call double and give it 10, or you can do exactly the same, which is 10.double, because 10 is an instance of an integer in this case, so it will work. Or you can even drop the empty parentheses, which is absolutely awesome. Although, because this, what this resembles suddenly is that, hey, there's a property of double, of that number 10. There's a property called double, because while this says, hey, there's a procedure double, right? Because in so many programming languages, we're used to a situation where whenever you see those parentheses, we know, we're executing some kind of function, method, procedure. So I would say that it would be good to still call things that way, just to avoid that confusion. Because if you have something like this, you expect like, this already has been calculated. Not a lot is going on when I'm calling that. So, it's basically free, right? Because we're just accessing some existing field. While here, we're doing some action. Something might be happening. So maybe in this case where it's just, times 2, and we're not really worrying too much about performance, it's not that kind of subject, then maybe it's fine. It's weird subject. But if you would have, for example, something a little bit more complex, where, you have something expensive happening within that procedure, I would definitely avoid the syntax. Then I would definitely go with that, and probably would be like, not like get double, maybe calc double to calculate, or some verb that suggests that, computation is happening, therefore it's expensive. That's a little hint on naming. Now, when using the unified function call syntax, is that correct? Uniform call syntax. Uniform call syntax, okay. To think about procs as member functions. So when using that to think about procs as member functions, there is an important point to keep in mind about mutability. Consider this example. So you have the animal, right? We define increment age self animal, and we just allow it to increment the age. And we do var Sparky animal name Sparky age 3. This fails compiling with the following error. Type mismatch. Got integer something, but expected one of a lot here. If you try something simpler, if name equals name, self name cannot be assigned to. So I guess we'll need to put var in front of self, or like self is type of var animal. This happens because arguments to proc are immutable by default. Okay, the error can be fixed by marking the argument as mutable using var. There we go. We got the type of var animal, and therefore, and the same thing here. Therefore, we'll be able to increase or change that property. Now everything works. Note that ref objects can be mutated, and the following works correctly. Yeah, we have the reference object and... Oh, interesting. Oh, okay, because animal already assumes that this is a reference, right? Why is this? This is because self is just a pointer and is not being mutated. If you try to change the self variable itself, it would not work. Yes, we tried to do that a few streams ago, and you can actually define something, even though this is a reference or something. You can say, let's say we would go to this example here. You could define either this type of animal or var animal or ref van animal to be a reference type, or you can do var ref animal. And var ref would mean that it's a reference that can actually change. So you can, in this case, if it would spark something and then call something like, call the ink age, there you could actually make the procedure that creates a new animal that increased age, and therefore that will swap the whole self. And I think it might have changed the actual Sparky itself. Let's try that. That's a good question, because soon enough we'll be coming to those weird edge cases, and it's easier to try it out, in a small environment like this rather than with something more complicated. Yeah, straight away. But instead of ink age will be, let's call it ink age. We'll increase age, but what we will do, we'll just say var new Sparky is bam. Let's just call it that this is a var ref, okay? Although we can't get reference to that. Let's call it ref object. So I will call it animal ref, right? Animal ref. Name is Sparky. Age is, so we'll do name is the self.name. Age is self.age plus 1. And it doesn't like it. It's good here. We just need to now do something like self is new Sparky. So we just replaced what self was pointing to with that new Sparky. So we could create that first Sparky here, right? And then we do echo and we call it original. Well, that's Sparky is Sparky.age years old. Okay. And then we're gonna go Sparky.ink age, right? We're gonna increase the age of Sparky, and let's see if it actually changed it, where we're trying to get age of Sparky itself. If that's gonna change, that means that instead of modifying the existing Sparky, we just replace the whole variable here with a different one. Let's try it. My brain suggests that it should work, but you never know in some of those situations. So let's run it. Yes, it works. First one is 3 years old, next one is 4 years old. So that increased age, taking var of a reference to an object, allows to just swap the whole variable with something else. So you don't need to do a Sparky equals something. You just do that and magically replaces itself. That is powerful. You could do a lot of magic with that. Yeah, like automatically immutable, interesting things that update themselves automatically. Very cool. So continuing, we learned about the self var and ref objects that would work with that as well. Okay, let's move on to inheritance. NIM supports inheritance and dynamically dispatched, also known as virtual methods. Methods work in the same way as procs, including UFCS. But the runtime type of the object that a method is called with is used to determine which version to call. So inheritance is created with the off keyword in the type declaration of an object. Note that base objects that are going to be inherited have to inherit from root object, since an object type with no ancestors are implicitly final. Okay, so basically if we don't inherit from root object, we're basically locking the object that, hey, you can't inherit from it. That's interesting. This way, basically everything that we don't care about inheritance in suddenly acts as, it's as performant as possible, but it isn't even considered to be that part of, we need to look up that there could be something to inherit from. So this way we have things way more speedy. I like it. Compiler can optimize a lot by default. A method is overridden by creating a new method with parameter types of the subtype. Okay, creating a new method, parameter types of the subtype. Okay, so we defined, again, type animal. This time will be reference object of root object. So this will be our class from which we can inherit. And let's note that it's a reference object. Usually in programming, all the classes and those objects that you, basically different classes, because that's what will be called here. That's what an equivalent is. They are usually passed by reference instead of by value. So again, it has name and age. Now we have a new keyboard method, vocalize, and we pass the self animal to it. And we say string, and then we have the magical base. And as a base, it will return just, 3 dots, because I guess we don't have like a default vocalize for generic animal, so it'll be just 3 dots. Okay. And method, age human years. Okay. Self animal, and we do return integer, and by default we'll return just the age. We'll consider it's the same, but I guess we'll be able to specify for cats and dogs differently. So let's see. So then we can define a different type. We call it dog, also a reference object of animal. So that's on inherits from the animal. So what we can do here is method vocalize, give it a dog. Okay, so we don't give it an animal, we can give it dog, which is rather important. And we can give it woof. So I presume that this is where the whole override is happening. And we don't have the base here. Forgot what they named them, decorators, arguments, or something like that. None of those flags. And then we also override the age human years to do the age times 7. Okay, so that's simple. And then we can also get the cat. And with the cat, we override only the vocalize. We don't override the age human years. So I presume on the cat, you still can call the age human years. It will just get the base method. So let's see. We get animals, which is a sequence of animals, and we start it as empty. And then we can add the dog, call it Sparky, age 10, and then we add another animal. In this case, it will be an instance of a cat, Mitten, age 10. And then for all the animals, we can echo the vocalize and echo age human years. So I'd say the first entry for the dog, it will be woof, and then it will be 70. While for a cat, it will be meow and age 10 because it calls the base, which is self-age. Let's see. Woof 70, meow 10. Perfect. Okay. So this is understandable. I like that syntax. It's easy. And I guess you could do a search for off-root object to find all the base objects or search for the base ones. Okay. I kind of like that too. Rather than calling override everywhere, actually override will be nicer. Because whenever you see something, if there's override, that means it's overridden, and you would need to search for the base one. Well, here you see that there's no override here, so you don't know if this is overriding something or not. The other way around will be better, I'd say. Something like this stays the same, while override is here. I'd prefer that. It'll be easier to understand when you're browsing the code. But okay, I can live with that. So, should you use procs or methods? Since procs are statically dispatched, they are more performant compared to the dynamic dispatched methods. As discussed in this blog, use methods only if you need the dynamic dispatch. Okay, so the moment you see a method, because they're called exactly the same way, so use methods only for situations where you actually need to be able to override something. Then it makes sense because when you see method and there's no base on it, that means, oh, this is overriding something. At least as long as somebody didn't just skip it. Okay, makes sense. I still wonder what this whole base thing does. So last time when we were looking for, again, I forgot what those labels or I'd even call them decorators or arguments or something. I don't remember what they're called, but during last stream we used Claude, and apparently with the pure label for enums, it just gave totally bonkers explanation. Like, it wasn't really right. So let's try to copy this code and see what happens if we remove the base. If it changes something or if it doesn't. So we'll put that code here, right? We have all the same stuff. But for some reason, method is not a base. How so? I have base here. Let's try to compile it. Compiled, so I guess this nim suggest is just a little bit confused. What if I'm going to cut it out of the vocalize? Now it just says use base for base methods. Baseless methods are deprecated. Okay. So soon enough, if we won't have the base on it, it will stop working. Are deprecated. So right now it'll still work. We just get the warning. Okay, makes sense. So this is required for base methods. So if I would define yet another method, right here on a dog, let's say eat self dog, and it will be won't return anything equals, I don't know, discard vocalize or self dot vocalize. Okay, we'll just do that, and it will already complain that for base methods, you need to add it. Okay, so we have it very clear now. We don't need the keyword override. Only on the base method, we need to say that it's a base. Everywhere else where you see a method, you can assume that it's something that overrides the base class. So in that case, I'm not complaining that it doesn't have the override here, because it's very often that you have one base class or a base object, right? Where you define those methods, those base methods, and then you have several, 2, 3, 4, 5 different objects that inherit from the base one, and therefore you don't have to repeat override a million times. It just make it more readable. So in that case, I like this approach. And if somebody makes a boo-boo where, age humans doesn't have that, you'll see a warning, and soon enough, in a few next versions of NIM, it'll stop working. So I like that. Clears my concerns. So we know that use methods only when you actually need that inheritance. Testing subtypes. It is also possible to check if an object is of a given subtype with the of keyword. For example, let's print out if animal 0 is of dog, or is of cat, or is of animal. Oh, very interesting. So let's do it here. Let's copy it, and let's actually edit that code, because our current code prints vocalize age humans. So let's say if, and we can do a as an animal is off. Was it off? Yes, off dog. We can just do echo a dog. Okay, a dog named, and we can actually do a dot name, right? Because it's in a base class, that property. So we should be able to access it from whichever. Then else if a of cat, echo a cat being addressed as a.name, and else, or like if a of animal, echo it's an animal. And let's do else. It'll be basically, in other cases, will be we're not dealing with an animal and a surprised face. All right, there we go. We can just do dog. Let's make it fancy. There's gonna make a cat, animal. Animal is animal. It's a name. So here we have condition is always true, a of animal. Okay, I was wondering if it's gonna notice that. And yes, this is always true because animals already holds animals, so it doesn't matter. It will always print that. I mean, it would always print that unless we get that first. So let's try it. Let's run it. We have a dog named Sparky, a cat named Mitten. So I really like it. This is really easy to check if it is. And if it's an animal, even though it's a cat, so let's define one more animal. Type rats is reference object of animal. Method vocalize self rat. String is squeak. Let's continue with that. We'll save it. It doesn't like this thing here. It needs a parameter. Oh, yep, there's a colon there. So we should be also, let's put the rat between dog and the cat. So animals.add. Rat name will be, I don't know, I had a rat named Nanny. Age, they lived 2 years, not long. And okay, so we have that. And because we don't have a specific response for a rat, but it's still an animal, we should say it's an animal. There we go. It's an animal. Perfect. So our code works. This is very clear, works really well so far.